If you're involved with the shipping and the maritime industry, whether as a mariner or in a shore-based role, I think you must know about the process behind the building of a ship. So what is the story behind how a ship is ordered to be built and what goes on till the time a ship is built and delivered to the ship owners. So in that regard, I thought today I'll talk about the process behind shipbuilding, and I will take you through all the stages because prior to the signing of the contract between the shipyard and the ship owner for the actual construction of the ship, the shipping company, the financer, and future owners have already completed a long road of negotiations and considerations. So, unlike a car, most cargo ships are not ready for delivery in a wide range of pre-constructed models. So most new ships are designed and constructed following the specific demands of the shipping company. However, more and more ships are built in larger series on a standard design with limited variations between different ships. So more or less, if you are building a cargo ship or a bulk carrier or a container ship, they are pretty much built according to a standard design. Now this makes a series production possible. You can make a lot of those ships quickly, and it helps to enable the shipyard to increase its production efficiency. So if they build similar kind of ships, they can do the work quicker because they are of standardized designs. So the container ships will be of a particular design, the bulk carrier will be of a particular, the ro-ro ships or any other tanker vessels, they all are, if they are built to a standard design, they can be built faster. Now, the advantages of a standardized ship and the disadvantages of a standardized ship are always, of course, there. So prior to the signing of the contract, of course, the owner or the shipping company will make it specific to the shipyard whether they want to build something to a standardized design. But before they do that, they have to consider the advantages and disadvantages. So the advantages of a standardized ship are: the clients know what they can expect. The design has already proven itself and can be optimized during the series. The price and construction are exactly known. The almost complete absence of the design and engineering developing period shortens the delivery period of later ships in the series, because once the shipyard has built a ship and then they have to build similar ships, they can work faster. And the cost for design and engineering of the ships are spread over multiple ships, so the overall cost per ship are lower. However, building standardized ships also has its own disadvantages. The disadvantages of a standardized ship are: the design may not be entirely suitable for the demands of the shipping company. The involvement of the shipping company is limited to only details. And more competitors may operate the same ships that are not optimized for a particular trade or shipping company. In spite of the disadvantages, shipyards have introduced goods and versatile standardized ships in the recent years. Some shipping companies are now ordering whole series of these ships with sometimes only a few modifications to the design. However, each modification of course costs the shipping company extra. In terms of owners' requirements, most shipping companies first define formal owner requirements, in particular if the ship will be newly designed and optimized for the shipping company. This is a list of demands which the ship has to fulfill. It specifies several characteristics of the new ship, like the desired carrying capacity and tonnage, the desired service speed and trial speed, types of cargo the ship must be able to transport, cargo hold layout, system of hatches and hatch covers, the necessity, capacity, safe working load and type of cargo gear, preferred suppliers of the engines, auxiliaries, navigation equipment, cargo gear, etc., number of crew and passengers to determine the number of cabins, composition of the crew, luxury and dimensions of the cabins and general accommodation, operational area, operational range to determine the size of the fuel tanks and storage compartments, limitations to the size of the ship in respect to the routes it will navigate, for example, bridges, locks, water depths, etc. Special demands like strengthening for navigation in ice if they are ice class vessels, or ramps on the side of the ship, If freight contracts have already been made, the ultimate completion date and required certification, classification society, as well as flag of registration. The shipping company then submits this list of demands as a call for tenders to several shipyards. The shipyards will then inform the shipping company if they are interested in preparing a tender for design and construction of the required ship or ships. This may depend on the technical capability of the shipyard and experience with the ship type, the capacity and earliest delivery time that the shipyard can offer, the amount of material and manpower that is required in the available time, special interest of the shipyard to build such a type of ship, expected price level, and expected competition. After informative talks, the shipping company sets a time period in which the shipyards can submit an offer or a tender or a quotation without any kind of commitment or engagement. This means that the shipping company does not have to pay for the offer and that the shipyards do not know which one will get the contract. Sometimes the shipping company already has a preference for a particular shipyard and then the offers are used in the negotiations with the preferred yard. The offer without engagement or commitment is the response of the shipyard to the invitation to tender. This offer consists of a preliminary design, which in turn consists of an outline specification, a preliminary general arrangement plan, and an estimation of the price. The outline specification is a brief technical description, and the general arrangement plan is a side and top view of the ship which shows the arrangement of the relevant spaces in the vessels. On the basis of a comparison of the offers, a shipping company will continue negotiations with 2 or 3 shipyards. The preliminary design for the tender is prepared in the project department or the design department of the shipyard. This requires a lot of calculations and design work, especially if the design is entirely new. What you see on your screen is an example of what a legal part of the new building specification looks like. Here, of course, the vessel's requirements and demands are laid out in a form of a contract, and the shipyard will have to decide whether they can fulfill the requirements and the demands of the shipping company. The demands on naval architects, computer-aided design programs, and designers are quite heavy, and if the shipyard is too small to carry out such an amount of design and calculation work in a small period, they may cooperate with other shipyards or subcontract the work to specialized design offices. Various CAD, that is computer-aided design computer programs, are used for the activities such as the design and optimization of the hull form, general arrangement of hull, decks and superstructures, hydrostatic calculations both for the trim and stability of the ship in various loading conditions and for checking stability in case of damage to determine the chance of survival. So the program actually simulates the similar conditions that a ship may encounter at sea and then checks the behavior of the ship and then builds the ship accordingly, or they plan to build the ship accordingly. So they also take into account the hydrodynamic calculations that are performed to estimate the resistance of the ship and to determine the characteristics of the ship's propeller and its propulsion efficiency from which the power to be installed can be derived. So from these calculations, the speed power curves are derived. In these curves, the required engine power is plotted against a certain speed, usually for trial and service conditions. So the ship's behavior at sea and its maneuverability at different conditions of the loading are simulated and then the behavior can be predicted. So the CAD design information is the basis for the calculation of the building cost of the ship. That will be mentioned in the offer from the shipyard to the ship owner. After having studied all the offers, the shipping company can make a final choice for a particular design and start negotiations with 1 or 2 shipyards to finalize the contract price and specification, resulting in a contract for the building of the ship between the ship owner and a yard. In other cases, the shipping company can elaborate their chosen design, prepare a detailed building specification of the ship, and a preliminary cost estimation. This detailed building specification of the ship owners can then be sent to 2 or 3 shipyards for a more detailed offer to complete the design and construct the ship. Now this document may be hundreds or 200 pages long. It's a thick document. So this procedure is called a tender, and participating in it is called to tender. For state-owned companies, sometimes they demand an open tender in which other shipyards can also partake. Sometimes it can take months for the shipyards to detail the design and the specification of systems in the ship to be built and to calculate an accurate price for the tender, but they still do not receive any money. There are still no obligations or commitments. The financing scheme has to be determined, often together with the bank of the shipyard, to negotiate the invoice periods with the ship owner. Some shipyards may offer financing scheme in which the ship owner only pays 10% at the signing of the contract and 90% at the delivery of the ship. This can be more attractive to the owner than a payment schemes that require advance payment to the yard before even building has started. Finally, the order will be granted to one of the shipyards. In this choice, just the price is taken into consideration, but also other factors like the delivery date, the efficiency, the reputation of the shipyard, and if the shipyard has constructed a vessel for the shipping company before. Remember, it works pretty much similar to how a house is built, but of course on a much broader scale. So you think about it, if you have land and you want to build a house, how would you go about? So you would be talking to a lot of builders, you will be taking tenders, price quotations, submitting your plans. Of course, if the builder has their own plans, then it will be easier and more efficient for them to quote a price. So that is how it works, pretty similar to that. If you have ever built a house, you will know that, or if you ever build one in the future, you will know how it all works. It's pretty similar to that. So after all this, the contract and everything has been done, sometimes after all this work, sometimes lasting up to a year, the parties that are involved sign the final building contract. So the building contract establishes all the legal positions and commercial conditions between the shipyard, the shipping company, and often also the financier, and is always related to signed contract specification and a signed general arrangement of the ship. So when the building contract has been signed, all the parties have obligations that start with the first down payment and end with the delivery on completion and the final payment. The shipyard gives a yard number to the future ship, which is stated on all the drawings and documentation. So you will see, if you see the plans, the general arrangement plan or any other plans, and I've made videos on that as well, you will see at the bottom of the plan, normally in the bottom right hand corner, you will see the yard number is mentioned. That is the yard number I'm referring to. So at this point, once the yard number is allotted, the clock starts to tick for the time of construction. So within the contract, there will be a provision to allow for price adjustments should any changes to the original design be made at some stage during the building period. So out of the contract, if the shipping owner, if the shipping company or the ship owner, they start asking for some modifications to the design, there might be some price fines, or rather you would have to pay extra money. It's just like a house, once the design is set and everything done, if you try to make any modifications, you will have to pay extra money. So for any alterations or additional components compared to the contract specification, the additional price will be estimated, negotiated, and fixed. The payment will be settled at a later date in accordance with the provisions made in the contract. Now, of course, if the alterations are not major, sometimes the shipyard may not even charge any money. Depends on the relation they have with the shipping company, how much ships have been ordered, how much money is at stake. They want the business. They don't want to offend the shipping company or the ship owner either. So the building time as agreed in the contract comprises the design phase and the building phase. The design period varies from 6 to 18 months, depending on the complexity of the ship. The building period varies between 6 and 24 months. A building team may be formed by the shipping company and the shipyard, who both appoint project managers, who are responsible for the entire building process until the delivery, each person in his or her own field of expertise. So what you see on your screens right now, this is how the ship's model is simulated. So here you can see on your left side, this is the wave pattern before optimization, and on the right hand side is the wave pattern after optimization. So this is to see how the different models of ships behave in different sea and wave conditions, so that they can design the most optimum design for the ship can be then produced. So most shipyards have a project or design department in which preliminary designs are prepared and where the final design calculations are made for the ship designs that then become ship contracts. Now these final designs will be elaborated in every detail of the construction and systems in the ship in the engineering department. This engineering department used to be called the drawing office, but nowadays in most shipyards the engineering is prepared behind workstations by engineers using computer aided engineering systems in most shipyards. There is not a single drawing table to be found these days, of course. The ship is elaborated in detail in construction drawings. The diagrams of all the mechanical, hydraulic, pneumatic and electrical systems are detailed, and the accommodation is also drawn in. Most relevant drawings have to be submitted to the classification society where the ship is to be classed, and to the regulating body in the country where the ship is to be, of course, registered, which becomes the flag state. So even though people from the shipping company are in the building team, some drawings still need approval from the management of the shipping company. Furthermore, every detail of the engineered construction or system has to comply with the rules of the classification society, which regularly sends their inspectors to the shipyards to assure compliance with initially approved drawings. Some shipyards have a small engineering department, mostly focusing on project management. They will subcontract the engineering package to an independent marine engineering office to their co-makers for the electrical installation, engine room installation, aircon installation, etc. Or they will cooperate with other shipyards. The detailed engineering of a ship design to a complete and approved set of drawings takes tens of thousands or even hundreds and thousands of man-hours. This is costly and as a rule of thumb up to 10% of the total building price. In many countries, there is a good cooperation between the various shipyards, and standardization has led to a better match of products and computer program. This makes it increasingly easy for shipyards to build parts for each other. Now you can draw comparisons again between how a ship is built and house is built, because even when you're building a house, say if you have a land and you're building a house, often the builder may subcontract electrical work or plastering work or roof work to other subcontractors with whom they have a good relationship. For certain difficult areas of design, specialist research and engineering firms are approached. These firms can advise the shipyards in the optimization of the shape of the ship, the calculation of noise and vibrations, the optimization of the propellers, ducts, and rudders. Research on the hull is done both by computer calculations and results of model testing in a model tank. That is what I was showing you before. So the resistance curves are obtained by measuring the required propulsion power at different drafts and speeds. In addition to this, research is done on the influence of waves on speed, the necessary propulsion power, navigability, rolling and pitching behavior, and maneuverability of the ship. With very large ships, of course, research is done on the extreme forces and moments of inertia that arise in the ship in case of heavy waves and seas. In the Australian Maritime College, we also have facilities of towing tank where such simulations are carried out to study ship behaviors as well as behaviors of the simulators, or rather the submarines, not the simulators. Now the optimization of the ship's shape is a very laborious task where measuring and calculation go hand in hand. Now I showed you before the wave pattern of a ship at a certain speed before and after optimization. After optimization, the ship makes fewer waves, so the optimization procedure has reduced the wave resistance. The bulbous bow has already reduced this resistance because the wave produced by the bulbous bow contracts the bow wave. However, this is only one effect that is accounted for in the optimization process. There are many other effects that can further minimize the wave resistance. Now the production preparation department gets the construction drawings from the engineering department to prepare the material ordering list and the job descriptions for the production of the block sections. Every individual steel part gets its own individual code and description, type of material, block, section number, etc. With the aid of a computer program, a nesting engineer nests a collection of steel parts with the same material type and thickness in rectangular steel plates. The goal of the nesting process is that the construction parts for the ship are located in such a pattern in the available steel plates that there is minimal amount of waste material after cutting all the parts out of the base plate. On the numerical controlled steel cutting machine, a computer also controls the cutting torch. For instance, an autogenous flame cutting torch or a plasma cutter in a water bath. Now in the wet plasma cutting process, the excess heat is drained quickly and the cutting fumes are absorbed into the water. Some shipyards use dry plasma cutting where a vacuum system below the plate draws the fumes away. I'll show you what a plate cutter looks like later on. I have a photograph of a plate cutter as well. I'll show that to you. So because of a plate cutter, minimum distortions will occur in the prefabricated steel construction parts, and there is a good control of the exact dimensions of the plates. The cutting machine also marks the code number of a part on the steel. A ship is constructed in various stages which can sometimes overlap. Prefabrication of steel parts, building of flat panels, building of block sections, assembling of hull and deck house on a slipway, installation and outfitting of systems and components, painting of individual parts, final painting layers on the outside hull, launching of the ship, outfitting along a subsequent completion, system trials at the shipyard, sea trial. There's a lot going on and there's a lot of things involved. So automation of the construction has led to more efficiency in that case. Furthermore, the sections will be engineered in such a way that as much assembly welding as possible can be done by semi-automatic welding and robots. Building by block section enables parts of the double bottom, the foreship and the aft ship to be welded whilst lying upside down in the workplace. This way of welding produces a uniform quality of the welds with less production time. Because access to the different blocks is much more restricted when they are joined together, the ship systems are pre-outfitted in the sections as far as practicable prior to the joining. So all these parts of the ship are built in different places, and then they are brought together to be joined together. So this means that the piping systems, tanks, fillers, filters and other small auxiliaries are all placed in the section before the joining of the blocks. The building of a ship used to begin with the placing of a keel plate. The rest of the construction was then connected to this first item. Today, laying the keel means that the first bottom block is placed in the assembly hall or on the building berth. Subsequently, the other blocks of the ship are then built to or on this. At this stage, the production is well underway. Some modern shipyards do the actual building in a large indoor assembly halls where they use pre-painted steel plates. You can see that I'm trying to show that to you in the diagram or in the picture here. So after welding, the plates are joined and immediately painted. So several factors determine where the ship will be finished. The finishing is either done in the assembly hall or at the outfitting dock. So you can see here there's a photo of an assembly shop here. So in some cases, the deck house cannot physically fit into the assembly hall. So if the vessel is going to be launched longitudinal, the vessel should have the minimal amount of weight on the board. The launching of a ship can be longitudinally or transversely. I'll show you some pictures and then you understand what is launching of a ship. So transverse launching means sideways launching. Longitudinal means, of course, it is as per the length. It goes front, either the aft is launched into the water first or the forward part of the vessel is launched into the water first. And depends on the layout of the shipyard and the slipway, and is always an exciting moment because at the moment the ship is launched, there is no way of stopping it. There's a lot of water that splashes around it. And this is a big occasion, of course, in the shipyard when the ship is initially launched. So let's talk about launching and outfitting. So in longitudinal launches from a slipway, the ship acquires so much speed that it takes a lot of effort to reduce this speed. This is done by water brakes and drag chains or ropes. In side launches, and that is what you see on your screens right now, it is done from a transversal slipway. The ship can bounce back against the wharf, especially when the water level is high. The ship does not gain much speed but produces very high waves instead. So after the launch, the final items like mast, hatches, sometimes the engines, funnels, ventilation shafts, cranes, they are all added to the ship at the fitting out berth. Finally, the cabins and other spaces are furnished and the inventory is bought on board. So inventory is not a yard supply. They are supplied by normally independent suppliers and vendors. So when the ship's electrical systems are ready, the switchboard is connected to the shore supply to get power. After careful checking, a diesel generator is started and electric power from the generator is supplied to the switchboard, and the ship can then begin to function independently from the shore power. Upon completion of the vessel in the shipyard, the final testing of all systems will be conducted at the shipyard, with the exception of items which can only be tested during the sea trials in the open sea. Now let's talk about commissioning. I don't know whether you know what commissioning is. During commissioning, a very important item is the inclination test and the lightweight measurement test. I've talked about the inclination test in a separate video. Maybe you can find it in the folder of ship stability. I have a lot of videos on ship stability and one of them is on inclination test. The inclination test is carried out to find the position of the center of gravity in height. So moving a known weight from midships to both sides alternatively and measuring very accurately the list during the various steps in that procedure make it possible to calculate the position of the center of gravity in height. This is a very important figure for the stability calculations. Final testing at the shipyard is related to electrical systems, engines, generators, pumps, technical equipment, life-saving equipment, light ship weight measurement, and of course, like I said, the inclining experiment. In principle, all these tests will be carried out in the presence of the owner's representatives, classification society surveyors, and sometimes even the flag state surveyors or flag state representatives. Final testing in open sea is mainly related to final testing of machinery under working conditions, fuel consumption, vessel speed, rudder test, and anchor test. Next is the first technical sea trial, which can take from a few hours to several days. This is the first time that the ship leaves the shore and is completely self-reliant. The ship as a whole and all of its parts are extensively tested and all the results are carefully recorded. The classification society and the flag state are also present to see if all the demands are met. In general, these trials are successful, but there are always small issues and imperfections which can be corrected during or after the trial. The exact behavior of the ship in open sea will become clear when the ship is in use. However, the speed and fuel consumption of the empty ship can be measured during the sea trials. More and more shipyards advertising short delivery periods and more shipping companies demand. In order to facilitate this trend, lots of shipyards subcontract other shipyards to build parts for the ship. It is also common that the hull of the ship is constructed in low-wage countries, cheaper countries where they have to pay less for labor, and that the hull is fitted out and completed locally. But even without these measures, all the semi-finished parts must be ready for the next phase of construction to commence. Besides, all the purchased parts must be ready in time, but not too early because the cost for the storage and the interest keeps changing, and sometimes it can go up to large amounts of money. So keeping the construction process manageable requires that a proper overall planning of the project in terms of technicalities, logistics, and finance should be available any time of the day. Such a management system integrates and controls data from the production or the preparation, design, purchase, stocks, administration, and project management. The shipping company and certifying authorities will finally accept that the ship subject to the issue of the relevant certificates and successful sea trial test. During a short voyage, the protocol of consignment is signed. The shipyard's flag will be exchanged by the flag of the shipping company, and the financier, they pay the last installment. Because there is usually a 12-month period of guarantee on the ship, the shipping company usually requires a bank guarantee from the shipyard. This is called upon when the shipyard cannot or refuses to comply with the guarantee. It is normal that in the first month of the ship's life, a guarantee engineer from the shipyard is on board. Sometimes it's not the case because I have been on ships where it has been delivered newly, and we have to go around the ship and find out things that are not working. There are issues, and the things that were promised by the shipyard were not delivered, or some components of the ship are not performing to the standards. Then you have to make a note of this, and before the 1-year period ends, the ship goes back into the shipyard and claims can be made. So the shipyards will they will either rectify those, they will address those, or they will suggest another shipyard which is convenient to the shipping company and get them rectified there. The guarantee conditions are an integral part of the building contract because just like any other product, the ship has a period of guarantee. Normally, this is about 12 months after the delivery of the vessel. The shipyard almost always takes over the guarantee conditions in the periods of the companies supplying the different ship components and transfers them to the ship owner at delivery. Now I know this picture is not in reference to what I'm talking about. This picture is actually of that of a plate cutter. Remember I told you I'll show you a picture of the plate cutter. So I found this picture of a plate cutter, and this is what is used to cut the plates of different sizes in the shipyards, and then of course use them for so this is of course I'm going a bit off topic, but I remember that I told you I'll show you a picture. So this is that picture. So if the ship needs repairing within the period of guarantee, the vessel's location and the urgency of the repair jobs determines who will repair the vessel and where it is done. So if the ship cannot be repaired by the shipyard, for instance, because the ship is in another country or another port, the shipping company is allowed to have the ship repaired by a third party, but only if the cost of repairing the ship are not more than the price the shipyard would ask. This condition protects the shipyards against excessive bills if there is a deal between the shipping company and the repair yard. So repairs of components and equipments are almost exclusively done by local service dealers, especially when the parts of a well-known brand. This is always done in consultation with the shipyard or the supplier. The crew is prohibited to do repairs during the period of guarantee unless the repairs are absolutely necessary to the operation of the ship. If this is the case, the shipyard has to be contacted for consultation first. Sometimes suppliers have 2 periods of guarantee for their product. The first period covers some months after delivery from the factory. The second period covers some months after the product is put into operation. The reason for this is that there are sometimes a long period between the delivery to the shipyard and the time the component is put into operation.